For this session, we're going to look at global variables versus local variables and the concept of a constant. All right, so let's start with local variables. We've seen this before where we declared a local variable within main, such as int a, and maybe assign it a value like this, okay? So this was an initialization. Now, can we have also a variable that we don't initialize? Int b, no problem. Which means later on we can go ahead and assign a value for b. But we can only access a and b within main. That is why they're called local variables. What other kinds of local variables can we have? Now, a and b are read-write, which means you can write to them. Just like b here, I didn't assign any value. I can go back later on and do b equal 7. Not a problem. Okay? So this is a write. Can I print what's in it? Printf. And we've seen this before. Is simply say b equals %d /n to give me a new line, and simply b semicolon, and let's compile and run this. Okay? And you get your b equals 7. So b is simply a variable, and which means you can later on change it to another value. B equals 6, and that is why it's called a variable. Now, everything we're going to see are variables. It's just a matter of, do you have permission to write or read, or simply read? And variables that will be read-only will be considered constants. So it's kind of similar to constants mathematically, but not exactly. We're going to still call them variables. You can refer to it as a variable constant if you want. So b after alteration or after assignment or reassignment equals, and that would be a %d. And let's look at b again, and that's not a problem at all. B will have, compile and run, will have the new value, and it's a 6. Let's put a /n there. As you can see, press any key to continue is run next to it. So it's probably a good idea to do a /n. That's why we do it. And let's compile and run again. And there you have it. So b after reassignment equals 6. Okay? Now, here's another kind of variable. So these are read-write. Right? So I can read them and I can write to them. I can alter a as well. Now, what if I did this? Const, the keyword const. And then let's say we're dealing with an integer. And let's call this one val. Now, the variable name is val. You could name it whatever you want, right? I could call it my const if you want. You can name it whatever you want as long as you do this. All letters are capitalized. It's a convention. You could leave it lowercase, but you'll have to assign a value, 8, for example. Okay? So you must assign a value. Now, as I said, by convention, we want this to be all uppercase. Why? That way, when we refer to val again downstream and we're reusing it, we know it's a constant. We know we can't change its value. Let's compile this for now. Let's go ahead and now compile and run, actually. You can see nothing happens. Really, with val, we didn't do anything with it. Can we read it? Can we read what's in val? Right? So can we actually printf val equals, and then %d, it's an integer, /n, and then val. But refer to it as val, all capitalized. That's how I declared it and assigned it a value. If it's a constant like this, you always assign a value. You will see why in a second here. So compile and run. And you can see now val equal 8. Now, why do we assign it a value? Okay? Because you want it to start with that value, and you cannot alter val downstream somewhere. So if you try to do this, val equals -2, and I try to compile this, you will get an error. Right there. And this is a structural error. It cannot change or reassign a read-only variable. So val is a read-only variable, Hence, we consider it a constant. So that means the value that's in it remains that way. So the moment you declare it, you have to also assign it a value. So this is important when you're dealing with constant. Now, it happens that val also was declared within main. So it is still a local variable to main. Okay, so now, can we look at a global variable? What is a global variable? That is something you declare outside of any function, including main. So it would be written right here, okay? So something like this. Maybe it could be a float, it could be an int, it could be any data type. I'm just going to stick with int for now, much easier. And I'm going to call this one C, semicolon. Now, C is a global variable, which means I have access to it from any function, which means I can go in here and let's go ahead and do this here. C equals 9, and then display that. Printf C equals %d, and then /n, give me a new line, and then simply C. So I have access to C to read it, and I have access to C to write to it within main, and you can handle it as if it's a local variable. However, it was declared outside of main. Now, that has an effect if we had other functions. Any value you give C, the last value you give to C, is what the other functions will see. And again, we haven't done functions yet. That's another lecture, another lesson. But be aware, and this is why it gets complicated. So that means if you alter C somewhere during your program by some function, and you didn't pay attention when and how, you could easily end up with a confusing or a result that can lead to confusion. Okay? So right now, let's look at how this works. Go compile and run. As you can see, not a problem. C is equal to 9. Okay. Now, variables that are stored in as constant versus variables that are stored as local variables within a function are stored in different locations in memory. There are reserved spaces for these. And again, I urge you to go down. There is a special lecture on how memory is utilized in C. Okay? That applies to C++ as well. So I urge you to look at that lesson. It's just a few minutes. It's not that long. And it will tell you where global variables are actually stored and where local variables might be stored as well. Okay? All right. So now we've seen the level of access to any of these variables. All of these variables have addresses, regardless. So because they're stored in memory. So nothing magic there. So I can still printf C's address. C is located at this address. And that would be still an integer value, /n. Now you can express that integer value in hex if you want to. We're going to leave it as a base 10 or a decimal value. So you could say n%c, and we can see that it actually has an address, right? So compile and run. And there he is, right? So now let's look at the address of A, for example. Okay, so printf A, and that's C lowercase. All your variables should be lowercase except for constants. And notice these addresses don't have to be next to each other. Again, that is because of the way they're assigned due to their nature, due to where they were declared. Were they local? Were they global? Okay, and let's compile and run. And notice A is in a totally different group. Notice this one, it starts at 4. That's a really high number versus this one. Okay. Now, again, urge you to look at that lecture on how memory is, basically distributed, or the variables are allocated to what areas in memory, whatever they're declared, either global, constant, initialized, not initialized, and local. Okay? All right, so now you've seen that. So can I have a global variable that has a value? Absolutely, you can initialize. So let's call this one f equals, it doesn't have to be an int, let's do a float. F equals 7.8. You can do something like that. That's not a problem. So let me compile right there. Okay. Now what I cannot do is try to print right here, for example, as a global instruction. You can't do that. You can't do this. Printf f equals %f, which is a float, /n, and then f. You will get an error. So if I compile this, okay, we're going to get an error here. Okay, this has to run within a function. In our case, we only have one function called main, so you can only call this function printf. Printf is a function within main. So can I cut this line and store it and rewrite it in main? Yes, and that would run. So Command V here. So compile and run, and there you have it. So you have your 7.8. Now notice here I did not set up the precision on how I want the output, so it will automatically go to a default precision for the output. Can we set the precision to 2 decimal points or 1 decimal point? Yeah. So if you want 1 decimal point, notice where I have %f. Just say %.1f. So 0.1 would set it to 1 decimal point. So we'll get our 7.8 to look exactly the same way. You need to recompile this anytime you make changes. And there you have it. So now your output doesn't look as strange or too precise to where it does not reflect that that's what you stored, 7.8. Okay? And yes, 7.80000 is the same, but that's a lot more precision than what we need here. Okay? We get to see that later on when we start comparing float numbers against each other. So again, that's another lesson. Right now, so what did we learn out of this? That you can have local variables and global variables. And you can declare global variables or give them values, okay, when you declare them. You can initialize them. You can do the same thing with local variables. And you can also have constants that are either local variables, and we could have also a global variable like this, const, and float. Now you could say pi equals 3.14. So I could use pi, for example, if I'm doing some trig or something like that, trigonometry. I could use that pi somewhere in another function. Okay, so let me compile this to show you that this is just fine. And that way, pi is available for all other functions as we move. Right now, let me remind you, the only function we have is main. Now, you might say, how about printf? Those are functions. Yes, but these are function calls. They're not actual function definitions. What I'm writing here is the actual work that it's supposed to do. You're going to say, well, system, it's a function. Yes, but we're calling it. So functions will be called. Okay? So we've got a few lessons downstream where we'll understand the difference between function definition and function calls. Okay, so let me repeat again. Local variables, global variables. And can you use pointers on any of them? Absolutely. Okay? All right, so that's another exercise some other time. And we will use pointers eventually. So I'll see you for the next lesson.